Hello everybody, we are here to do another screencast lecture. The unit topic is changes of state, and today's phase change is going to be vaporization. Now, an important thing to remember, a real quick review, is that when phase of change occurs, there must have been an increase or a decrease in thermal energy. When thermal energy is absorbed or released, matter can change from one state to another. The 6 types of phase changes that we'll be studying in this unit are listed below, and of course, like I just said, we are going to be focusing on vaporization. So let's get started talking about vaporization. Imagine that you spill liquid on the floor. You come back several hours later and it's gone. What happened? Well, it's magic. It's a miracle. Well, of course, you probably know that that is evaporation. And evaporation is a form of vaporization. That's the phase change, vaporization. This is our phase change going from a liquid to a gas. Here are some photo examples of vaporization that you may be familiar with. Here you see some cooling towers at a nuclear power plant. This looks like pollution or smoke, but it's actually water vapor. And hopefully you know something a little bit about the water cycle. The evaporation or vaporization is a very important part of the water cycle, getting water vapor into our atmosphere. Vaporization point. We know from before that the melting point is the temperature at which a substance will melt. The vaporization point is the temperature at which a substance changes from a liquid to a gas. This is a temperature. For example, the temperature, the vaporization point of iron is over 5,000 degrees Fahrenheit. Here's a video clip. When we think of something that is vaporizing, we often think of things that are very hot, like boiling water. However, it doesn't necessarily have to be something that we would consider hot. Like, for example, liquid nitrogen actually vaporizes at negative 321 degrees Fahrenheit. Most of us would probably consider that not very warm at all. Here is a video clip about liquid nitrogen.
Steve, we're doing this all with liquid nitrogen this
Yeah, we are.
morning.
Okay, put on your glasses
Okay.
so we don't get the emails.
Right.
Nice. Got it?
Got
All
it.
right, perfect.
We're set.
Now we've got to have something that's cold. And so kids sometimes mistake this for water when you show it to them in school.
Right.
But this is liquid nitrogen. About 79% of the air that we breathe is nitrogen. And if you take that air and you compress it and you get it really cold, you get liquid nitrogen that really is not happy to be out right now because it's normally 320 degrees below zero.
Wow.
And so now it's boiling away. So it doesn't have to be hot to boil. It's just boiling away because there's enough energy there to be able to let those molecules release. Now grab some of the flowers.
Okay, you get much nicer flowers
Here-
for your
here
wife,
you go.
Steve.
So this goes down inside. So now we can actually extract the petal. Got it? So here
Yeah.
we go, here we go, here we go. Now hold out your hand. It's perfectly safe.
Really?
It's okay. Just crush
Really?
it. Squeeze it.
Whoa!
Isn't that
Oh,
just
that's really
amazing?
chilly.
Isn't that amazing? There
Yeah.
you go. We squeeze like this. Extremely cold. So literally we can extract the scent from there as well.
Oh, cool.
That's just amazing. And it always makes a mess wherever you are. And then these sit on your desk, which is kind of a
Have their stuff.
absolutely. Hey, here's a balloon that I blew up. And so
Right.
this has my breath inside. But if we get my breath really, really cold,
Yeah.
it's one of those things that we have to worry about a little later on with our tires. Is that you never? Are you worried?
I'm
Look at
scared
you.
that thing's gonna explode or
no,
something,
no.
Steve.
Because it's cold, it's going to now shrink, right? So those molecules
Okay.
are getting closer and closer together, so it shrinks. And if we're careful, we can, see, did the little bell go off?
It
right?
did,
Ding, ding,
like
ding,
what
ding, ding.
happens in
See?
winter with our tires.
That's exactly right. And so you have to be careful not to fill your tires too full in the wintertime because when it heats up, then they get a little bit more pressure. Look at that. That's my breath that's inside as a liquid, and now it starts to turn back
How
into a
cool
solid.
is that? that?
Is that fun here? It's this. I have this on the funnel, so now I can get some of the liquid
Right.
nitrogen like this. If we pour a little of the liquid nitrogen in, it just proves that it really wants to turn into a gas. So here, watch this. So now,
Oh, cool.
so now this is turning into the rest. You want to do this over
Yes,
here?
let's
All right, so
do
let's do
this.
this. All right. So now move this over here like
Okay.
this. All right. So now let me scoop up some of the liquid nitrogen.
Right.
And now it's okay. Hold on to this.
Really?
No, I'm serious. It's okay because it's styrofoam.
Okay.
Now here's what I want you to do. Just pour it inside. Just go ahead. Nice. Nice. That's just beautiful. This beautiful little
awesome.
cloud. I'm going to put some stuff on the website about liquid nitrogen because there's a way here that in Colorado that teachers can get a liquid nitrogen kit to play with. So. I want you to hang on to it. It's 320 degrees below zero, okay? So I'm going to just kind of scoop some up like this. So this is our liquid nitrogen
Right.
here. So it looks like water, but it's not. And so here, watch this. This is hot water. So if you take some of this liquid nitrogen and pour it into the hot water, I want you to see the little cloud that we make. Ready?
Okay.
Okay.
Oh,
No, dump the whole thing in. That's
Okay.
fine. See how that works?
Yes.
Here, so watch this. See, isn't that kind of cool how that just kind of goes everywhere?
yes, it's very
That's
cool.
kind of fun. All right. So, a really good idea. You stand behind the shield.
that's
okay?
what I
All
was thinking.
So this is the liquid nitrogen. So we need about 20 liters or so of the liquid nitrogen. Okay.
Yep.
All right. So this is. Let's just see what that looks like. Oh, we need more. All right. Now the directions call for about 1.5 liters. But I was just kind of thinking that this would be good. All right, so I think that'll be perfect. See you later. All right, here we go. You ready? All right, here we go. 3, 2, 1. That's cool. Pretty awesome. Here's some fun.
Here's a demonstration of vaporization of paraffin. What is the vaporization point of water? Of course, vaporization point means that we're going to have a temperature. The vaporization point is going to be either measured in Celsius or Fahrenheit. The melting point, if you recall, of water is 0 degrees Celsius, which is the equivalent of 32 degrees Fahrenheit. Boiling point of water is 100 degrees Celsius or 212 degrees Fahrenheit. And when we always think about phase changes, we want to think about energy levels. If we have the solid substance, let's say we have solid iron, the energy level for solid iron is lower than the energy level for liquid iron, which in turn would be lower than the energy level in iron as a gas. There are two types of vaporization. This is where it could get a little bit confusing. The first type that we're going to talk about is evaporation, and then we're going to follow that up with a short discussion of boiling. Evaporation happens at the surface. This is where vaporization takes place at the surface of the liquid. And the way this works is that if you recall, temperature is the average kinetic energy of the particles in a substance. The thermal energy of the particles will differ dependent on what particle. Like, for example, this one may be moving faster than this one. And if one of the particles at the surface actually gets enough energy, it can change phase going from a liquid to a gas. It has to be a significant amount more of energy. As you recall, when we're talking about energy levels, solid is a very low level of energy. Liquid is a little bit higher energy level than solid, but gas is way up there. So gas is going to be significantly higher in energy level than particles in the liquid. And phase changes always require energy. So in this case, we're going from a liquid to a gas. you're going to have to increase the amount of energy. So you're going to have to add energy to the liquid to get it to become a gas. Here's an example of how vaporization can help you. When you sweat, thermal energy from your body is transferred to the liquid sweat on your skin. That sweat is going to evaporate, and when that sweat evaporates, it takes thermal energy from your body, because again, going from a liquid to a gaseous state, it requires thermal energy. It takes thermal energy from your body and cools your body and lowers your body temperature. How can you increase the rate of evaporation? There's two things you could do to increase the rate of evaporation. One of the things is to recall that evaporation is a surface phenomenon. So if we increase the surface area, we increase the chances of more particles evaporating. So if we know we have the exact same amount of particles here than we do here, in the second case, in this picture, we can have a higher rate of evaporation because we have a greater surface area than we had in the first example. The second way that we can increase the rate of evaporation is to add energy. So in other words, we want to make the particles move faster. We can do that through increasing the temperature, like heating it up, put it on a stove, putting things out in the sun, or we can stir it or shake the particles, and that could increase the amount of kinetic energy as well. Here's a video clip. All right, now it's time to talk about boiling. Boiling is when vaporization takes place throughout the entire substance. So it's not just at the surface like evaporation was. The particles anywhere in the substance actually have the ability to become a gas and to vaporize. It has a lot to do with pressure, which is kind of beyond what we're going to be talking about in this lecture. But the particles in the fluid, in the liquid, can become a gas and escape through the substance. And when that happens, that's when you're going to see bubbles, because you're going to have particles underneath the liquid actually becoming a gas, and that gas is less dense and is going to rise to the surface of the liquid as bubbles. Here's a clip. Well, folks, that's all we have for you tonight. Hope you learned something, and we'll catch you next time. See ya. Be careful, kids. Bye. Bye.